Hello, I welcome all of you in my second video of the chapter Factorial Design, chapter 5, Design of Experiments book. In this video, we will study about regression models and the response surface. So first of all, I will explain what's the regression analysis. Regression analysis is a method in which we found out the statistical relationships between a dependent variable and independent variable. So let's write a simple regression equation. You have studied the regression equation maybe in a metric or FSC that y is equal to mx plus c. So here was over a dependent variable we represented by dv, m is the slope of the line, and x is the independent variable plus c is the constant, and we call it y-intercept. So we make the regression equations in design of experiment very frequently in order to statistically find out the effect of various factors on the response variable. We call we call x, that is our independent variable, we call it x is as our factor, or another word is used, you can say it's our variable. X is our independent variable, okay, or independent factor, and then we call it y is our response variable. Sometimes we call it outputs, and we call it x also our inputs. We call y our outputs, y as our quality characteristic, quality characteristics, and it is our dependent variable. So all of these are frequently used interchangeably names for our dependent and independent variable x and y. Don't get confused in that. Okay, few of the models, regression models, are simple regression models, and another word type is multiple regression models. What's the difference between them? If we want to regress a single independent variable, like in this model where there is only one independent variable and one dependent, and we want to find the effect of this independent variable on the dependent variable, so we call it simple regression model. So when there is one independent and one dependent variable. In case when we got more than one independent variable, means you can say x1, x2, x3, we say it multiple regression model. Okay, if you want to find out the effect of in the notation we say that speed, feed, depth of depth of cut on the material removal rate. So material removal rate will be over response variable, or you can say over dependent variable, and speed, feed, and depth of cut will be over independent variable. So this is all about. Then what will be the effect of this slope on the, so slope, if the slope is positive, we say that if we model it using graphically, we will say that if there is you can say draw a line. So if the slope is positive, the line will goes up. If the slope is negative, that's positive m, and if the line goes negative, you can say it's the negative slope. So how we'll write this generic equation for the simple regression equation? You will say that y is equal to b naught. So b naught is over y-intercept, where the line is intersecting with the y-axis. So this is over, you can say c, or sometimes we call it b naught, beta naught. Okay, so b naught plus beta 1 x, again y dependent variable, x independent variable, the slope of the x is beta 1, and beta naught is over you can say y-intercept. So this is all about simple regression. Then for the case of multiple regression, I refer you to this equation. Here we have one dependent variable and we are regressing dependent variable by using two independent variables x1 and x2, and also the equation that contains both x1 and x2 in their product. This term is known as interaction term for the two factors. We will say that this term will tell us that what is the effect of interaction of these two factors on our response variable y. Okay, so the interaction should be illustrated by using the regression model. Suppose both factors are quantitative. Quantitative means that they have the we can say numeric values. You say that over a speed has a value of 1000 rpm. Okay, feed you can say 0.1. Okay, depth of cut you can say it will be 0.05 mm. So like this, these factors are quantitative. The regression model could be written as follows. So this is our generic regression model for two factors. Now the question comes that how these lines tells us. So I'm going to tell you in detail about this regression model by using my MSc research work. I've drawn the similar models in the Origin software. These are basically color models, and they are quite good for explaining to you that what is the role of regression modeling and how we can use them for the graphical illustration and graphical interpretation. So it tells few different regions. The green region have low value of the output, whereas as we go towards the dark reddish region, the value of our response variable is getting increasing. Okay, so I have regressed the effect of I've found the effect of preheat temperature in case of welding. I did the welding in my research work. So I want to find the effect of preheat temperature and groove angle on the tensile strength. So greater the tensile strength, better will be the our values. Fine. So what I do, I say that the first level of the preheat temperature here and the you can say first level of groove angle, it will give me the highest tensile strength, because the intersection of these two values is giving me the dark reddish region. Further, you can say that this plane has been tilted upward. So as the upward value will give us more tensile strength, so the tensile strength is maximum at these points. I will explain one more if I have these. Yep, I have also these for the impact energy. So this is one of another table. I am going to another graph to explain you that how we can interpret it. So explain this one. So in this you can see that I have taken the factor electrode diameter and preheat temperature, and I found the effect of these factors on the impact energy. So what you will say that the highest impact energy in this region and this region have the third level of electrode diameter and third level of the preheat temperature, and we got this. Also you can see that the plane has been tilted upwards. So this is our maximum point at which we got our impact energy as maximum. We will get back to the presentation. So the question comes that we have so far we have cleared about what's the regression analysis, simple, multiple, what the equation tells us. Now how we can find out these coefficients beta naught, beta 1, beta 2, as we are using the experimental data to find out our regression analysis equation. So instead of beta 1, I use beta hat, means beta hat. I'll use beta naught hat or beta 1 hat. Why are you using estimated value of the betas of the coefficients? Because these values or this data has been based upon the sample values, and from the sample, so sample values is estimating or giving me an estimate for the whole population. So that's why I using the estimates for all of the variables. I will use example 1 to explain you that how we will make this regression analysis equation. First of all, beta naught is the estimate, or you can say is the y-intercept. So how we will calculate beta naught, I'm going to tell you that. So beta naught, I will say that beta naught estimate of beta naught. So very simple. We have four observations or four values of the response variable at four different settings. So just take the sum of all these values and then divide it by 4. In short, take the average of all the 4 values. So you will say that 20 plus 40 plus 30 plus 52 and divide it by 4. You will get 35.5. So you got the estimate of beta naught, and this estimate as it has been written there in the equation. So this is over 35.5. We have done with the first value. Then we will calculate beta 1. So look at this, beta 1 is written with x1. Okay, so beta 1 is the estimate of first variable. So we will write the estimate of the first variable beta 1. This will be equal to, so what is the effect of a is over a first variable? So the effect of a is 21. So keep in mind that whenever you divide effect of the variable by 2, you will get its coefficient. Okay, so I will divide 21 in this case, 21 divided by 2, so 10.5 is the estimate of my beta 1, or 10.5 is the slope for the first variable, or it is the effect of first variable on the response variable. How will interpret this? We will say that an increase in 1 unit in this equation, it is written 10.5 here, where is written, oh yeah, it is written in the beneath, that an increase in, you will say that an increase in 1 unit, it is here, that an increase in 1 unit in x1 will increase 10.5 value in our response variable. And again, this beta 1, this has a positive sign, there is no negative sign with beta 1, so it has a positive effect on the response variable. So we can say that with the increase in beta 1, over response variable will increase. So I'm going to quickly calculate for the beta 2. What we will do, we will just divide this 11 divided by 2, and we will get over coefficient, that is 5.5. So it has also a positive effect on the response variable. 1 unit increase in the x2 will increase 5.5 units in the response variable. So this is x2, and then I will calculate beta 1 2. Beta 1 2 is a joint effect of, or interaction effect of, the first of the both factors on the response variable. So its effect is -1 divided by 2, and it is equal to -0.5 and -0.0. Okay, so it's minus basically. So it has a negative effect. It has a negative effect on the response variable. But keep in your mind that the value 0.5 is too smaller than as compared to this 10, and as compared to this 5.5. So we can ignore it. Further, the effect is so small, so minute, that this interaction effect is found to be negligible in this graphical representation, because when the interaction effect is very significant, instead of getting these straight lines or these straight planes, we got a curvature. We got curves in order to find the joint effects of the factors on the response variable graphically. So what I have did in the last slide manually, in this slide it has been performed. So 21 divided by 2, we got our estimate beta 1 10.5. Then in the second slide, we will get the answers, or for our beta 2. Look at this. Okay, beta naught has been calculated, or take average of all of the values. We got beta naught 35.5, and then look at this. If the interaction is very strong, in case we got a regression analysis equation, and where the interaction effect 8, it's found to be a very significant one. You can see, look at here. For the x1 x2, if our coefficient data is like that, our coefficient got a high value. Now 8 is more than the effect of x2, and it is highly, we can compare this coefficient with the effect of x1. So we got little bit curvature, we got little bit curved graphs. Okay, like this you can see, instead of the previous graph, this graph has a little bit curvature, and we will then find out its okay, how will you say that in case of the curve graphs, how will you say that where the maximum value lies? So the maximum value, again, it lies at the top, and I will suggest you people to use the Origin software that I have built all of these plots in the Origin software. This software will give the results very good, in a very good illustration for your research work, or for your research papers. Then in the next video, I will tell you that what is the general two-factor factorial experiment we will discuss in detail. Thanks for watching this video. If you have any comments, you can contact me directly on my WhatsApp. My email address has been provided. You can do comments of in the video. If you're new to my channel, kindly subscribe to my video. Thanks a lot for watching this video. Bye bye.